Hello everyone. In this video, we will be discussing some of the questions of data science. So let's dive into it. So the first question is, how is unstructured data analyzed? Unstructured data refers to the data that doesn't conform to a predefined data models, such as text, images, audios, or videos. Analyzing such data involves transforming it from into a structured or semi-structured form to extract meaningful insights. So in this unstructured data can be a text, image, audio, or video, which can't be pre-processed in the data models. So for pre-processing of the data, we have to transform the data into a structured or semi-structured meaningful insights. So steps involved for analyzing unstructured data are: first, data generation. First, data collection. Gather raw unstructured data. So here we gather the unstructured data, just like customer reviews, emails, social media posts, etc. Second process is pre-processing. Yeah, cleaning and normalizing the data. Text, remove punctuations, stop words, lowercase conversions, humanizing and cementing. Here we remove the punctuations from the text, stop words, lowercase conversions. We convert all the cases in the lower cases. Images, resize, filter, noisy, or enhance clarity. If we want to pre-process the images, we just resize the image, filters the noise from the image, and enhance the clarity so the model can identify the objects. Audio, convert speech to text. For pre-processing audio, we convert the speech to text so that the model can be applied on the data. And third is feature extraction. Convert unstructured data into structured form using appropriate technique use. So we convert the unstructured data to structured data by using some techniques which are for text conversion. We use TF, IDFT, or word to VC or BERT embeddings. For image extraction, we use feature vector using CNS, CNNS. For audio, we use spectrogram or MFCSS. Pattern discovery, applying machine learning, natural language processing, or deep learning techniques. We apply machine learning or deep learning process on text by semantic analysis, topic modeling, entity extractions. And for image, we use object detection, classification, and for audio, speech recognition and semantic detection are used. Interpretation, visualization or summarize in slides using dashboard, graph, or report. The final step is interpretation. We use graphs like plot graph, hash graph, or bar graph for the summarizing in slides of the data. So next of all, we will be going to the next question, which is how text mining techniques you can automate the process of classifying written complaints. So for automating the complaints classified using text mining techniques can help automate the classification of written complaints by transforming unstructured text into structured formats and using machine learning or rule-based approach to categorize them. For text mining techniques, we use the classification of written complaints by transforming the unstructured data into structured form so that the machine learning techniques can be applied on the structured data for the classification of the complaint. Step to automate complaint classification are data collection. Collect complaints from various sources like emails, form, or customer support logs. The first step for the automate complaint classification is to collect the data from the from resources like email, forms, or customer support logs. Second step is data preprocessing. Data preprocessing contains some of the steps in it, which are text cleaning. We remove the noisy and punctuations, special characters, and HTML text from the text. Lowercasing, we standardize all the text by converting it into lower cases. Stop word removals, we eliminate all the common or iterative symbols like full stop, iterative words like the and is. Tokenization, we split the uh, paragraph into words or phrases. Laminization or stemming, reduce words to their root forms, like delayed to delay, so that the machine learning techniques can be applied easily. Example for pre-processing of data is given here. So for the Python, we use we use stop words. Here we remove the stop words from the data. The complaint is written over here, and the laminization we does the laminization over here, and then we tokenize the words to the lower cases. Then we clean the tokens word. So the next step is feature extraction. Feature extraction consists of bag of words (BOW) represent text as a count of word. It just represent the text as a count of words. TFIFD, term frequency inverse, document frequency, wages terms based on the frequency and importance. Embeddings used pre-training models like VC, GloV, or BERT for semantic understanding. Example for TFT Python code is this. Here we vectorize the data and the data is printed over here. Next topic is next step for the text. Uh, Next process for automating the text mining is model selection. Choose a classification algorithm depending on the complex and size of the data. So there are some of the algorithms which are new bills, simple and effective for small data sets. It is very effective for the small data sets. Support vector machine SVM, performs well on the text classification task. It performs very well on the classification of tasks, text classification of tasks. Deep learning use models like RNNs, LSTMS, or transformers. Example BRT for complex datasets. Deep learning is used for the complex datasets. Next process for automate text mining is automation workflow pipeline. Create an end-to-end pipeline that includes pre-processing, feature extraction, model inference. Deploy the pipeline as a service to process new complaints in real time. Evaluation. Use a labeled complaint to test the model and evaluate metrics such as accuracy, precision, recall, and F1 score. All this evaluation process we have covered in the video tutorial, so you can just recall it from there or get reference from there. So the next we will be talking about the advanced techniques for automation. First is multi-label classification. Complaints can belong to the multiple categories, for example, delivery, delayed, and product damaged. So there are multiple categories for the complaints. So there are delivery issues and product quality. Use algorithms like logistic regression with one versus rest OVR or deep learning models like BERT. So here we will be using logistic regressions or deep learning models. Second, we have topic modeling for unsupervised classification. If categories are unknown, use topic modeling techniques like latent Diri- Dirichlet allocation (LDA) to discover compliance themes. Entity recognition and rule-based system. Combine name entity recognition (NER) to identify keywords. Example delivery delay with rule-based systems for classification. NER is used to identify keywords which are present in the complaint, so it is helpful for the model to identify the problem. So, example for the NER, we have to import a library called specie. Then we allocate that with the variable, and then we print the text from the variable from the files. Benefits of automating complaints classifications are effectiveness. Benefits of automating complaint classification are efficiency. It reduces manual efforts and processing times. It reduces all the manual efforts of the human, and the processing time is also very less. Scalability handles a large volume of complaints. It can handle a large volume of complaints and classify into it in a very short time. Consistency ensures uniform classification standards. Consistency is the main key that it ensures all the uniform classification standards. By leveraging these techniques, we can automate the classification of written complaints with high accuracy and reliability. So moving to our next question, which is consider the following complaints suggest the appropriate approach algorithms process to identify applicable IPC or RNS sections to recommend applicable BNS board national category sections or IPC Indian Penal Code sections. First, complaint is thief of my mobile phone by an unknown person at MG Road on 2023 February 2023. The phone was stolen when I was shopping at the store. The thief was wearing a black jacket and has a scar on his face. So the approach for identifying applicable IPC or RNS sections for the complaint are complaint text. The complaint text is as similar as it is given in the question. So we'll move further for the processing of the text. Pre-processing the complaint to extract essential elements. Steps for pre-processing of data is converting all the words to the lowercase, removing punctuations and stop words, tokenization and memoization words, use name entity recognition NER for structured data extractions. Key extraction elements are crime, which is done is thief, object stolen is a mobile phone, location is the MG road, and the date for the happening is 20th February 2023. Details of the thief is unknown, and he was wearing a black jacket and he was having scars on his mask. So this code will be implemented for this automatic for the automation of the complaint registration. So features engineering are convert the complaint into a format suitable for machine learning or rule-based analysis. We have to convert the complaint into a format suitable so that we can upload the data for the machine learning to work on it. So structured features are crime type is a thief, keywords from the complaint are theft, stolen, mobile, name entities are date and location and object. Technique use we can use TF, IFT or Word to VC or BARC for embedding for textual representation. Next, we have to perform algorithms, sections, and processes. So, approach one will be rule-based mapping. Create a keyword to section mapping using domain knowledge of the IPC or BNS. For example, thief is an IPC 378. Mobile phone thief is subcategory of IPC section 378. So this is the Python code for allocating the sections for the complaint. Or this was the first approach that we can apply it on the complaint. We can also have the second approach in which we will be using machine learning. So first we will collect the label complaint with their corresponding IPC or BNS sections. Second, we will be modeling section. In the modeling section, we will be train the text classification models such as logistic regression for simple classification, random forest for multi-level classification, BERT for semantic understanding of complex complaints. And then implementation, we will be using pre-trained BERT embedded for text classification. So we will be using this whole Python code for the classification of the text. Then the next step for the identify IPC or BNS section is NER for abstraction. We will be using name entity recognition for abstracting crime types, objects, and locations. Semantic understanding, we will be using embedding BERT or word to VC to match complaints with legal sections. Classification models, we will be training a supervised model on label data to recommend appropriate sections. Validations, we will be using cross validations to assess performance of the model. Next step is applicable IPC BNS section for the complaint. Applicable IPC section will be IPC section 378, where dishonestly takes any movable property out of the possession of any person without their consent, consent is in the IPC section 78. A possible board national category BNS section is BNS section 101, thief related occurrence. Next, we have to create a matrix to validate the system. So there are some of their metrics are precision, percentage of correctly identified selection among all the recommended sections, recall percentage of applicable sections correctly identified by the system, F1 score, harmonic mean of precision and recall, confusion matrix, analyze true positives, false positives, and false negatives. By following these approaches, the system can recommend IPC or BNS sections for the given complaint with accuracy and consistency. So now moving further to the fourth question, suggest suitable data structure and algorithm for the question three, which was the complaint automated complaint detection. So for detecting the data structures, and also we have to uh, answer that suitable data structure algorithm for question three. Okay, it is repeated. Cancel. So yeah, we have to suggest the data structure and algorithm which we can use for the question three. So to identify applications of IPC and BNS section for the complaint, we need to choose data structures and algorithm that enable efficient processing, analysis, and classification of textual data. So data structures which will be using are text presentations, which includes a bag of words, POW, represent text as a vector of word counts, TIFTF metrics, weights term based on frequency and importance, embedding embeddings using dense vectors representations like example word VC, GLOV, or BERT for semantic understanding. Dictionary, a hash map, store mapping between keywords and BNS sections. Example, thief is IPC 378, stolen is in the IPC 378 tree, prefix tree. Store keyword for fast matching. Example used to match phrases like mobile phone thief or etc. Graph represents the relationship between entities like crime type is applicable to applicable sections. So by graph we will be identifying that which crime is so by the help of the graph we will be identify that the crime is in which the section the uh, crime is noted. So algorithm used in the automatic complaint recognition or rule-based mapping use keyword matching to map complaints to predefined sections. Example, thief maps to the IPC 378 section. Text classification, supervised machine learning. Logistic regression, new bills, SVM for smaller datasets with feature-based representation. Deep learning like BERT and LSTM for semantic understanding of complex complaints. Example, fine-tune BERT for text classification tasks. Name entity recognition we use NERT algorithms to extract entities such as crime type, data, and locations. Similarity algorithms use cosine similarities to compare the complaints text with description of IPC and BNS sections. Example, match complaint embedding with pre-computed embedding of legal sections. Multi-level classifications handle cases where a complaint may map or multiple sections. Just before in the previous question, we see an example that the delivery was delayed and the product was damaged. So for for classification of multiple complaints or multiple tokens, multi-label classification are used. So example algorithms are for random forest with multi-level support, BRT with multi-labels classification. So moving to our fifth question, suitable metrics for accessing performance in text mining evaluation for question number third. So here we are asking for the suitable metrics which we can use for the question number three, that is automated complaint recognition. So we can use precision and recall to evaluate often the correct IPC or BNS sections are identified. Second is confusion matrix analysis cases where the model misclassifies or misses certain sections. Error analysis checking for parameters, patterns or misclassifications. Example, if robbery is mistaken for thief. So by using this metric, the performance of the algorithm can be rigorously assessed and optimized for better accuracy and reliability in text mining. So yeah, we can apply this all techniques for on the our model so that we can get a better performance of the model. So that's all for the day. You can just go through the video again if you couldn't understand any of the thing. Thank you so much for watching this video.